Okay. Hello, everyone. I guess we're going to start. So, hello and welcome to Silesia Wrocław JUGs event. Our guest today is Piotr Przybył. Piotr will tell us about what's new and noteworthy in Java 16. Today's event is the second part of the event. Well, we kind of co-organize with our friends from Wrocław JUG. We encourage you to ask questions because we have tickets for those who ask the greatest questions. For those are the conference tickets. Yeah, and during the event, I will interrupt Piotr and ask the questions from the chat on your behalf. So yeah, this is all from me. Piotr, the stage is yours. Thanks.
Hello. Well, I'm still sorry that this is a virtual stage and we cannot meet in person. So just as Marcin told you, my name is Piotr Przybył, and today is supposed to be the second part of our joint deep dive of Wrocław JUG and Silesia JUG to find out what's cool and interesting in Java 16. And roughly speaking, today we're going to cover records, which are like a huge change to Java itself and maybe even Java ecosystem in the future. We'll see. And we'll also cover some minor stuff. And just as Marcin said, if you have any questions, please don't wait till the very end. Ask them in the meantime, so we will try to address them as soon as possible. And the most active participants or the authors of most interesting or intriguing questions will get a free ticket for JLove conference. Okay. So let me just switch to slides. Okay, slides are supposed to be here, and my talking head should be here. All right, yeah. So this is a it's May 25th. It's a part 2 of our meeting. By the way, if you find out that I'm talking way too fast, please let us know as well. I have this nasty habit, sorry. And of course, today, since it's not a conference but it's a Java user group, we have more time, and hopefully we'll be able to answer all your questions. So don't worry. Shortly about me. So as I said last time, I'm self-employed as a remote freelance software gardener. You can send me direct messages if you have them and you'd like to ask me something in private. You can send me a direct or private message on Twitter or Telegram. And I'll blog every now and then on my page, softwaregarden.dev. And before we jump to records, there's one more thing I'd like to bring your attention to, and this is we've seen, I mean, because the previous part was like 2 weeks ago, and we've seen a very nice email from Mr. Reinhold himself, and it was quoted by David on Twitter. And this is an email explaining the meaning of the term of long-term support, right? So as you can see, I'm not going to read this whole message through. I mean, the slides are online, the tweet is online, the message on the mailing list is online and public as well. So you can read it later on your own slowly and understand its true meaning or not. It's just I'd like to highlight the very last sentence, that whether the target list is an LTS or not is almost always completely irrelevant. So as you can see, it's yet another proof of the altitude or the idea of LTS, that it's like a business term, or it's nothing technical. Therefore, the LTSs are as important and as stable and as equal to other versions as if they were not LTSs, and so on. Like there should be, in theory, no big difference, except maybe from some corner cases. So whenever you find a reason to upgrade to Java, you should go for it, even without the reason. In fact, it's just maybe you should find a reason to stay on LTS, like Java 8, for example, your library or framework doesn't support. like the changes introduced by JPMS, or you have to stay on Java 11 because reasons, I don't know, like a business or crazy audit or something. But then please keep updating your JDK anyway, your JVM, because there are minor updates to Java 11 as well. Okay, so let me go to the records then. Yeah, records are here. So we've seen 2 releases of records as a preview feature in Java 14 and Java 15, and now we see them released as a standard feature in Java 16 as a JEP 3.9.5. And by the way, I suggest maybe you should read this JEP. I mean, not this time, but you as a kind of a homework or supplementary and everything else, because it really describes the history, the goals, and maybe most importantly, it describes non-goals as well. So it's, as you can see, one of the non-goals is so-called war on boilerplate. So in theory, it's not the the purpose of records to like combat the boilerplate, but to provide other means of carrying data and so on. But we'll see that in a minute. There are also other examples, how it works, how it doesn't work, what's possible, and so on. So this is like a part of the official documentation or release notes. Okay, so let's talk about these records, because this is why we're here, right? So record is a new kind of type declaration. So it's a restricted form of a class, and I like to think about records that they are like a distant relatives, or maybe even like a cousins of enums. So if you're kind of new to Java, let's say last few years, that's how I may define new from my point of view. Then there was a time we didn't have enums in Java, and they got introduced in Java 5, and of course this, then you have like a class, and of course you can add methods, and we have like a limited or enumerated, hence the name, instances. So these are objects, but there are some restrictions, and therefore there's a purpose of such a class and such a type, right? And the same applies to records, of course, in like a different in a different way, with a different meaning, but like the mechanics, broadly speaking, might be the same. So every record implicitly extends Java lang record. There is a new class, and it's like we cannot extend it directly. It gets extended indirectly. So it would work, for example, if you still like need to go for instance of or something. I mean, I can't imagine such a weird case, but technically it's possible. And this is a quote from the JEP. I don't know if it's this one or one of the previous ones, that the record is meant to be a transparent carrier. Sorry, I had made a typo here. The transparent carrier for immutable data. And let's stop here for a moment, because first you see it's a carrier for data. So it's a perfect candidate, for example, for DTOs or value objects and things like that. And it's immutable. So once created, once we have an instance in hand or assign it to a reference, this instance should not be mutated, and in by definition it cannot be mutated. So it's immutable, and transparent means that everything that's kept inside this record is visible outside, right? So it's like also, I mean, so far we were doing this, for example, using beans, which had every getter and setter mimicking exactly or mapping exactly a public field, like a public final field, right? So this is more or less this approach, and this is how we define records. So as you can see, instead of a class keyword, I'm now using record. So this is how we do that. We just say record, and then we say the name or the type of this class, and then this is a new thing. We have so-called record header, right? So we have a list, and the list, it looks pretty much like a parameter list, for example, for a constructor or a method, and it says what this record is going to carry inside, because it's a carrier, so we need to know what's going to be carried inside. So as you can see here, for the complex, we have just two pieces of data to be carried, like the real part and the imaginary part, and both are doubles. And then we also need to add a body. I mean, even if we don't add anything special, like no methods, no constructors, no nothing, then we have to use or enclose this empty body as well. this this is like the bare minimum to define a record. And of course it's missing here, but record can be just as any class, can be, for example, public, right? So the access modifiers, or better said visibility modifiers, apply here as well. Nothing changes. Okay, so what do records have? Records have a name, and of course they have the type. We'll get to that. And they have record components, just as we saw. I mean, the previous record had 2 components, but the list can be empty. So we could use like an empty parenthesis and it would work. I mean, I don't see much value for such a record, but in theory it's possible. And those components are turned into private final fields. They also have generated accessors. And they have generated full canonical constructor, and also based of the list of the components, they have equals, hashcode, and tostring methods generated as well. So as you can see, as you saw in the previous example, I didn't have to create these methods, yet they exist. They're generated by the compiler or runtime. We see them effectively in code, and they are like using all these components by default, right? Using their names and so on and so on. They are just mapped one to one. And they also need to have a body. I mean, records always have body, and this body might be empty, or maybe in many cases, and maybe that's even the ideal or a perfect use of a record, the body should be empty because we're not adding extra logic or anything like that. So let me switch to code. So we see records in action. The code is also online. It's on GitHub. You can fork it later and experiment on your own. Yeah, so this is the result. And as you can see, I am using this complex number. So I've defined one complex number, Z1, and another complex number, Z2. And now I'm able to multiply them, right? And this created me another record. And this record, then I'm able to print it out. Just as I'm able to print it out in here. Just let's see how this worked. So let me jump to this code, and as you can see, yeah, there's a formal definition or description of record on Wikipedia if you're eager to, like, if you didn't have it at university or something, like algebra and stuff. Okay, so as you can see, the record can be public. They have the record indicator, and then I'm going for the name or the type of the record, and again, here's the here's the list of the components. Yeah, and then my body isn't empty because I've decided that these methods, like an add method or a subtract method or multiply method, is so tightly coupled to this data. I mean, we can have operators in Java, at least for now, and maybe this will change one day, who knows, unlike Scala, for example. Therefore, I wanted to add the methods like add, subtract, and multiply, and of course they cannot mutate this very record. I mean, I'm using to call these methods. It's just instead they can return a new instance. That's why in all these cases I'm calling basically a constructor, right? And doing this highly sophisticated mathematics to get the proper results. And as you can see, I have also overridden the tostring method because this is the format I got used at university, right? So the real part is displayed as the first one, and then we have the imaginary part followed by little character or letter I. Okay, so if what happens if I don't have this method? So then when we rerun this code, what happens is that the default implementation of the tostring method kicks in, right? So as you can see, this is the default implementation. So it's the name of the record, like the abbreviated name without the whole package and everything like that. And then in square brackets, we have the first component and the value, the second component and the value, and so on and so on. This is how the story goes. However, if you don't want to have this default implementation of the tostring method, because I don't know, maybe there's data you don't want to have in logs or leak to user interface in an unprotected way or anything like that, or maybe you find another format more handy, just as I did for this one, then of course you can override methods, even those which were generated, including the tostring method. Right, so these are the elementals. These are the basics of the complex records. And yeah, just one thing I'd like to highlight you in case I don't know, you'll be having future like I don't know, review for job application, something like this. Record is not a restricted keyword, like unlike enum, for example. If I try to write enum like this, then the compiler will yell at me because enum is a restricted keyword, whereas record is not a keyword, is like if I remember correctly, it's like a restricted type indicator or something like this. All right. Nevertheless, it's not a keyword. I mean, maybe it's even valid for some certification or something like that. Anyway, let's go for more sophisticated examples. And one of them, I mean, the first one is we're going to cover what records can have, like what's possible in records. Let me see if we have that in slides. Yeah. So what records can? They can define and redefine constructors, full canonical constructor, compact canonical constructor, and we can also define custom constructors. So in theory, there are like 3 kinds of constructors of records. We'll just get to them, don't worry. And they might have, I mean, the records can have own implementations of generated methods, just as we saw for the tostring. There are also, of course, accessors, hash code, and equals, and we can override or provide our own implementation due to whatever reason. And by the way, they should obey the rules or invariants or the contract that's behind them, right? I mean, they should behave, roughly speaking. And records can also have extra methods, like extra instance methods, and they can also have extra static methods and static fields. And they can, of course, implement interfaces, and they can even be generic. For example, we might not know what's the type of a record component when we declare a record, and that's why we can use generic. And please keep in mind that these examples mean that something is doable technically with a record. It's not something that we should be doing with records, right? So it's just to illustrate you or show you the technical possibilities. So this is like a short demo of the options of records, like what's possible. And this is the output. As you can see, the code not only compiles but even runs without an exception. So now let's see what's possible, right? So as you can see, we can have a record without any field, and this is how it looks like. So it still needs to have this empty list of components and an empty body. I mean, it got formatted this way, but we could also have it like this way, whatever style you prefer. And then we can have records with one component, and then we can have records which are generic, right? So we say that we have 2 types, like serializable type and something that's a number, and we want to have serializable component and number component. And this, for example, can be anything that's serializable, and this can be anything that's a number, for example, a big long or a big double and things like that. So it's still possible. As you can see, I can have something that's here, it's generic record, and big long, for example, is both serializable and a number, right? And we can add also custom methods. So as you can see, I have a method here, print hello. So it prints just hello to whatever I passed here as an argument. It's just, I think it's a really bad example because this method has nothing in common with the data that's stored or kept in this data carrier, right? So just because this code compiles, I don't think you should be using anything like this in real usage. And there are also static members possible. So as you can see, I have the full field and I have the bar method, and they also work here. So I believe I was calling the foo method here. And now the thing is about the immutability. So we need to remember that records are immutable in the meaning that the fields or the components are turned into private final fields. But if the field itself is mutable, and for example atomic integer is, then of course nothing prevents us from mutating this field. So this code will work again. So I can have a counter and I can call bump on it, and then you see I bumped it 3 times, and then I printed the final result of this counter. So technically it's still possible. So please remember that records don't make your code like immutable, like deeply immutable. Records are immutable, but only to the in the first level, at the level of their fields. And we also can have for example, we can override the tostring method because why not? This is another example for this. And we can also create custom equals and hash code methods. I mean, we'll get a more sophisticated example later on. It's just, please keep in mind, they both should obey, behave, and so on. They should follow the contracts. And also, please remember, usually you want to override both of them at the same time, right? Even that's why I think an idea, you have to select both of them. And then we get to overriding accessors. So it's still possible to override an accessor. And for example, an accessor is like a getter, except it doesn't have any prefix like get or is or has been or was and whatnot. It's just exactly the same name as the component, right? So as you can see, the secret. So I have eventually like a private final field secret, and then I can also have like, or by definition, I will have an accessor called secret and returning me an integer. Just to match this type. And in case you want to have, I don't know, a side effect, because I think it's the only valid reason to obey the contract, because actually we are still, I mean, it's not a strict technical requirement, right? I could like in every case I can return, for example, 33 here. It's just, it doesn't make sense, and then I'm violating the contract of a record. That's why, I mean, some side effects only would make any sense. So in case we have something secret, for example, I may want to like log or stuff like that, that somebody is calling this accessor, right? So stuff like that. And as we've seen previously or in the slide, records can have different flavors of constructors. So we can have, and this is an example of custom full canonical constructor. I mean, it's custom because I customize it, but it's like a full canonical constructor because the list of the parameters of this constructor is repeated. It's exactly the same list as here for the list of the components, right? And I had to create this constructor because I wanted to have two invariants in my record, right? So I wanted to ensure that A is always different than B and C is always different than D. And this is only to illustrate that this canonical constructor has been called. That's it, right? So this is this call, just to illustrate. So this line isn't required. I wanted to add these two lines, and because I wanted to add these two lines, I don't know, like check, for example, a business invariant or something like this, to make sure I'm not creating records which doesn't make any sense, that are ridiculous. For example, this could be, for example, if I wanted to divide this by this, I would check for sure if B is different than 0, for example, because it's impossible to divide by 0, at least as far as I know. So because I wanted to have these two invariants, I had to repeat this list of arguments, and I had to repeat this list of assignments, right? And of course, it's an official non-goal to declare a war on boilerplate, but it looks like a boilerplate. Just because of these two lines, I had to add, extend this line and add these 4 lines. So luckily for us, this isn't required because we can go for a compact canonical constructor, or compact constructor, shortly speaking. So see, if I miss here or omit here the list of arguments, you see it's not even empty because it wouldn't work then, but the list is completely missing. That's something new. We didn't have such constructors in Java so far. Then I can, or the constructor will infer this list of components to be exactly the same, and then I can only focus on the actual business value or business needs. So I toss here these 2 invariants. These are checked, and I don't even have to repeat these assignments because they will happen anyway, right? So as you can see, and this is only for demonstration here for this line. So if I only want to check the data, add some invariants, then I'm free or allowed to override this so-called compact constructor, and then I don't have to follow this ceremony, right? So this is also possible, and there's a third kind of a constructor in records, and this is like a custom constructor or a non-canonical constructor, maybe better said. So as you can see, I have a record which is about keeping length and a hash, and let's assume it's for, I don't know, external cache of strings or something. So for example, I might want to use it in a map. I don't know if that makes a valid sense, like a valid use case, but still maybe it's possible, right? And then instead of making a constructor calls with string.length and a string.hashcode, maybe I just want to have these calls, right, something like this, wrapped inside my constructor. So this is like pretty much like calling this constructor in every other class or super. The same rules apply. It's just, as you can see, the list of the arguments doesn't match at all the list of the the list of parameters doesn't match the list of the components, right? And that's why it's a custom constructor. And yeah, the same applies here. And by the way, these custom constructors may have a lesser or visibility. I mean, they might be more restricted in visibility. See, this record is package default, as we know. Records in classes and interfaces, if we skip this visibility modifiers, they get package default, and this constructor can be private. So as you can see, it's working. I mean, or it's not, maybe not called. Yeah, it's not called, but it's possible. Yeah, one thing though, what happens if we try to rename it to hash code, right? I had to rename this field to be hash, not hashcode, because then we have illegal component name, right? Because it will clash with the hashcode method, which returns an integer with the hashcode and so on, right? That's why effectively we cannot have a component with the name hashcode. And yeah, as I've told you, records can also have or implement interfaces. So for example, if they are about data, it might make sense to compare them, right? To compare one instance against another instance. For example, so I may want to compare two instances, first using A and then using B, right? So this is it. So I can just say implement comparable. It means I need a compare to method, and this is that other instance, and then I'm just calling objects compare, and I'm using the comparator comparing that came with the Java 8 and so on. So first I'm comparing by field A, then I'm comparing by field B, and so on and so on. So as you can see, they can also implement interfaces, and also the accessors can use the override annotation. So as you can see, I can declare or redefine an accessor without any annotation, or I can add override as well. Although technically there is no such method in the code. It just gets generated on behalf for us on behalf of this component, right? But it's still like it's up to you whether you go for an override or not. I would say, in general, if I see in the production code like generated accessors, I would really need a good excuse to see it redefined, because for equals hashcode to string I understand, but what magic do you expect in an accessor? Okay, so this is about what can we do with records. Let me see if we have any questions.
Yes, actually there are some. Actually, the first question is record without components some kind of named reference to memory, like null?
I'm not sure how to understand and how to answer this question. I mean, maybe I'm basically too dumb. And how do we understand as named reference to memory? I know it's done in different ways and in different languages. It's just let's think about it for a moment how this would behave. So it might be kind of a similar to an enum. It's just we can have then only one instance of, many instances, but they would do exactly the same. So, and they would be restricted from having any fields, as we will see shortly. So I'm not sure what would they do. What would be their purpose? So maybe it's like I don't know. It's coming from the grammar or something like this. Like AST definition. But I don't see any practical usage for it. At least right now.
Okay, so the next question is also from Łukasz.
Okay.
And it is like, are there any plans for compact constructors for non-record classes?
I'm not sure if there are any plans like this, and I'm not even sure if it would make much sense, because for a record based on this of their definition, like this, right? So finally we have like it's like, because the beans were Java beans were kind of a how do we call that? It's like convention. It's not a formal specification or something like this. I mean, there was a specification, but for Java beans used as a part of the UI and so on and so on, right? So the components were supposed to be components, so people could drag and drop UI components in AWT or Swing to build their interfaces and kind of like wizards. And it's totally different for record, because record has record types have the scripted described meaning and a purpose and a role and methods that get generated and so on and so forth. That's why I think this compact constructors make sense, because we know what we're going to do. I mean, we're going to reassign these arguments to fields because these fields exist and these arguments exist, but it doesn't make sense for any other class. I mean, without this list of the components, I'm not so sure. So I don't know if there are any plans. My answer is I don't expect anything like this to happen. At least I don't see any reason for this to happen. So that would be my answer, Łukasz.
All right. So these are the questions so far. I
Okay,
think we
so
can continue.
all right, so let's follow with the slides. So let's talk about what records can't, because we covered what they can. Let's talk about what they can't. So they cannot extend classes, or they cannot be extended. Oops, sorry, wrong window. They cannot have anything like setters, except something like this bump method, as we saw in the previous example. They cannot have any extra or additional instance fields. They cannot have less visible canonical constructors, as we also saw already. They cannot declare native methods, and they cannot assign components in compact constructors, because in previous it was legal in a compact constructor to assign a value to a field. Now it's illegal, impossible, and I think it's okay, because that's not the purpose of the compact constructor, right? So let's let's go to the code, because I mean, I can put anything on the slides, right? It's just the code will tell us the truth as the ultimate documentation. Okay, so as you can see, these are the limitations. Again, let's run this code, because why not? And I'm accessing 12, so the code seems to be working. So as you can see, I mean, extending Java util date would be a dumb idea anyway, but nevertheless, records cannot extend anything. In fact, you can't even extend Java lang record, because the extends clause is just like forbidden in a grammar for a record, right? So it's not going to happen no matter what you want to extend. And also they cannot be extended, because records are implicitly declared as final classes. They cannot have like a super duper private field like we can have, for example, in case classes in Scala. It's impossible for Java classes. So it's like, that's why they are transparent. Like everything that's here must end up as a constructor parameter and will end up in an accessor, right? And also we cannot have anything like a setters, even mimicking this accessor follower method or pattern. So see, it's not going to work, because these fields are final. And also what's impossible, we cannot declare a native method, and we cannot have compact constructors which have lesser or weaker visibility. It's not going to work, as you can see. Sorry, let me roll back. The non-canonical constructors can have such visibility, right? So it's a non-canonical constructor, like a custom constructor. It's still possible to be less visible than the record enclosing this constructor. And what they can do also is just, now compact constructors cannot reassign fields. So for this to happen, I would need to have int a component like a full constructor, not a compact constructor, right? So when I have a compact constructor, it's not going to work. So these are the limitations. And if we take a look at this list of limitations, what that means is just it doesn't expose any state or whatsoever, or doesn't even put the state of the data inside on risk. I mean, at least at this shell level of the record itself, right? So that would be it about what records can do. And I think we have one question, right? So we have a question from Dappy. Hello, Dappy. Nice to see you. If native means static. No, I'm afraid native means native. You see, native methods, I mean, it's just, let's cover it for a few seconds. Native methods are something different from a static method, because native method means that it's going to be implemented not in Java, but for example in C, right? Under the hood is going to call the native code, and so on and so on. So implementation will be provided in different means outside Java language, basically. So static is about having methods in at the class level, whereas native means that the implementation is not going to be provided here in Java. So this is it. Okay. So let's go for another section. So let me just step back a little and tell you what records are or are not. So records are not Java beans, right? I remember like a year or so ago when records were about to be released as the preview features. So then a lot of people kept saying that, okay, we're going to have records, and the others kept asking, so what these records are, and then the firmer ones started to answer, oh, these are like Java beans automatically generated, and then some other folks started to say that no, these aren't Java beans because they're going to be immutable, and some used to say, okay, so they're going to be like Java beans, only they're immutable. No, they're not like Java beans. Like even immutable Java beans. Like Java beans are Java beans, like a convention or something on things we used to have in Java, or maybe even abuse for years. It's just records are pointers with accessors. They don't have any getters. They are implicitly final, and they are they have this like other methods generated, right? And you should think of them like named tuples. And for example, many people used to ask, when are we going to have like anonymous tuples, for example, like we have in Scala? And I don't think it's going to happen to Java, because now we have records which are named tuples, or as we could say, tuples which have name or type. And I just like to cover it briefly because I think I have a I know I have an article on this, or a post on my blog post, and explaining that, for example, this is a tuple, right? So when you get, like in SQL database, we love to think about rows, but this is like a visual representation. Actually, we have tuples. As you can see, I can select weight and volume from packages, right? And this is like a tuple with 2 elements. And maybe like many people used to create, for example, like a Java beans to represent that, or maybe using something like, for example, from Apache Commons, go like for per, right? Something like this. It's just things, or worse, using like a array of double, and keep like in hand that there are only 2 elements in this array for each row or tuple, and so on and so on. It's just things get complicated, because then we might have totally different relation in SQL, namely cos in this example, and we may select exactly the same tuple. It's just with totally different meaning, like millage and trunk volume, for example, because you'd like to know how many suitcases you're able to pack in, right? And then you can do something like this in SQL, and you can do something like this in Java if you're using, for example, double array. And then you're like mixing, for example, peaches with apples and so on, and you don't end up knowing what you have, and compiler won't warn you, or your I don't know, query planner or anything won't worry you, because this is technically super duper valid request or query to SQL, right? So that's why the records kicked in, you see, because they represent, like, I can have one record type to represent package size, and another one to represent, like, for example, a millage and track size from a car, and then they set, or as we saw with this complex, we have something like this, and because of that, I'm not able to add to this set package size, because it's like it's not the same type, right? So this is how you can see, my friends, what's the additional benefits of having named tuples or tuples with actual types instead of having just anonymous tuples. And just one more thing, sometimes they require overriding equals and hash code. I mean, I would say if you need to override an equals or hash code method, it means there's probably like a bad design or a code smell or something like this. It's just in some cases it might be needed or inevitable. For example, when you have a list that has to be or that's mutable, or another thing that's mutable, right? So as we know, when you have hash code or equals and you have mutable parts, then these methods become more tricky, so to say, and we need to provide special implementations. And this is not like something special to records. I mean, this will apply for any other like even regular Java bean or any other class. It's just we need to keep that in mind, right? I don't know if I have an example for that. Let me see for this equals and hash code. I should have an example. Yeah. So there is this, we can do a little riddle and let's see, for example, who can answer this, right? So who can answer this question first? My fellows, what I mean, when I was a child, we had these sweet bars in Poland. They were called records as well, only with K instead of C. And yeah, they were kind of like a sneakers, we could say. And let's say we have a factory for such candy bars, right? And the idea of this is like a bad design. For each record, I keep, what do I keep? I keep when this record was created and the list of locations. Like the factory, the first location will be a factory with this sweet thing was created, and then subsequent warehouses or shops or I don't know, logistics centers or something like this, right? Because I want to, I don't know, let's like put a label on this very sweet bar. And then we can have something like this. I can have a hash set for these sweet bars. And as you can see, I'm creating two bars, bar 1 and bar 2. And then I'm adding these both these bars to my box. And then they are packed and sent to different warehouses. You see the bar number 1 is sent to warehouse alpha, and the bar number 2 is sent to warehouse beta. And then just by mistake maybe, or just to be double sure, extra sure and double check things, we can add these bars to the same box again. And now the question is, how many records do we have in our box? Like, let me run this example, and you can check that in like put your answer in a chat. How many records do you think we have in our box? We have a few seconds lag, so let's wait for the answers and let me sip a little.
Maybe while we're waiting, we can answer the next question. What do you think?
I think it's a big one, so let's have it for a bit later. Okay. So, do we have any answers? How many records should be there in this box of ours? Or we don't have any brave souls? Like nobody wants to get a free ticket for JLove, for example. Yeah, so maybe I'll show the code again. 2 boxes, one of the answers, 2 boxes. Okay, 4 boxes. Any other answers? Maybe there should be, like, some say that the truth is in between or in the middle, so maybe we should have 3, or I don't know, 2.5 or something like this. Sorry. Let's see. Okay, let's just hit enter. And as you can see, despite we only called this constructor twice, and we can have had these 2 instances, the Java set thinks it has 4 boxes. So I think Krzysztof won our little competition, because yeah, this method here will show us. I mean, this is the code that shows us that we have 4 boxes. And why did that happen? Well, it happened because this is how hash set works, right? So it works. It just when it adds elements, it checks if an element is there by comparing the hash code. And because we mutated by adding this location, we mutated or changed the hash code. Hence, when we add them again, these sweet bars have different hash codes, right? So as you can see, things might be tricky, and it's not like a property of records only. You can do the same stupid thing with value, for example, from Lombok, or when you generate a method from IDE, and so on, right? So as you can see, this is what might happen. Let me just stop this code, and let's maybe explain that a little more here in this equals check. So how it's, oops, sorry, wrong key. Wrong class again, because we would like to go for this cache hash code, because also we used to get this question quite a lot, if hash code is cached in a record. So let me run this example again. So as you can see, I have a list of strings, an array list to be precise, and then I have a record. As you can see, here's the record, and it accepts the list of something, and then I have words, and I'm going to add, this is a method that prints hash codes of both the record and the list, and even repeats for the list itself, right? So we can see what list are we actually talking about. Right, and then when I'm adding word by word, you can see that the hash code of both the list and the record changes. And I mean, it's like an implementation detail that they are exactly the same, right? But you get the feeling. So just as the list changes, also the record or the hash code of the record changes, because this is how it works, right? So the default hash code method just calls hash code of every component and so on, at least for now. And it doesn't have any caching, or doesn't seem to have any caching. So what I would do in this example to make sure there is no such backfire, I would do several things. So first, I would make sure that we don't have, like, this list is immutable, right? So maybe I would go for, and I would add a constructor, like a canonical constructor, and then I would go for example, list a copy of locations, to make sure that this list is immutable. And then when I run this code, it should throw me an exception, right? Because of this call, I made this list deeply immutable, right? Because it's immutable as every implementation of list copy of, set copy of, and so on. So you see, I'm not able to change this list. I'm able to create a new record with double locations, and so on and so on. Another thing we could do, although I don't recommend it, would be, for example, to override this equals and hash code method. So we skip the locations, we say it's not relevant, and we identify our records only by the created field, right? And then let's even say that this should be not null. See, and then I have the hash code only for created, not for the location. So when we run this code again, so many records we have in our box, 2, and then we are added to see they don't change. And this is it. So please, like don't follow false prophets telling you that for records you should never write equals or hash code. I'd say it's true only to some degree. Like, you shouldn't be doing this, and whenever you discover you are doing this, it might be that the list of your components is like it's mutable, and that's the original problem that we should get rid of. But when it's not possible, when you're not able to create like a defensive immutable copies, then just you have to override equals and hash code, right? There's no other way how to handle it. Okay. So I think Krzysztof, you should after our meeting send like a DM to our organizer Marcin, so you can get a free ticket for JLove. And let's carry on with more examples. So nesting records. Records can be nested just like any other static classes, right? And these local records are very handy for streams, for using in reduce, or as intermediate results, for example, of collectors, right? Oops, I did that again. Sorry. So let's go for nesting records. Okay. Yeah, so this is an example of this. So as you can see, I have an enclosing class with a field, and I have inside class, right? So when I want to get, like in this inside class, I want to get the access to this field, then of course this class cannot be static, because when I make it static, then of course the compiler will yell at me, yeah, see, this is illegal, because from inside a static class you're not supposed, or nested class, you're not supposed to reach for the outer class, right? Or the class that's nesting you. And as you can see, exactly the same applies to records, which means that records behave as if they were nested classes. And if we go back to that list of what records can do, that makes perfect sense, because then it would mean that record can do something in their methods or accessors, for example, if that would be an accessor, and rely on the data that's outside its scope, right? And this field could be non-final, for example. So that's one of the possible explanations, I believe. Nevertheless, they behave or act as if they were nested classes. That's an important thing to remember. And let me go maybe for a more sophisticated demo. So I have this demo. Let me comment this out. And what does this demo do is just I use that demo for demonstrating T collector introduced in Java 12. And to make this example work, you see I have a simple stream, and this stream I have like 20 long numbers, something like this, and I want to do two things. I want to summarize the numbers, and I want to count the numbers. It's just I don't want to do that in two separate calls. I just want to do it in a single pass, in a single call, right? So I can go for a reduce method, and then I need like a accumulator and a result type. So this count and sum, and this is like oversimplified Java bean, right? Because I have public fields even without any getters. I have a constructor for both of these. They are final, so I don't need any setters. I don't have equals and hash code, because that's not going to be needed. I'm not using them like in I don't know, hash set, or I'm not persisting them. And then I only have two string for demonstration. So I can use that in a reduce, or I can use them in T collector, right? So let's run this demo, and let's see the results. Yeah, so the sum is 190, and there are exactly 20 numbers. So when I go for either reduce or T collector, I get exactly the same results. It's just, as we could see, this class is like, I mean, you know the drill, right? We first need to add like a static class or a separate class in the same file, or maybe like even like a public class in the package. It depends on our needs and visibility and so on. And then we have to add these fields. Then we use these shortcuts to create a constructor, and then to string, and then getters, and blah blah blah, and so on. Yeah, and this code is like, excuse my French, like this code is like damn simple. Like there's nothing special about this code. So how about doing something like this, right? So I just go and create such a record for us, right? And this is it. This is the single line definition. So again, I use the same names for fields. Therefore, I will have the same, or very similar, not the same, very similar to string, but I will have exactly the same constructors plus accessors and so on, right? So I'm going to call this code again, and you see the results are exactly the same. Only, despite it's not a war on boilerplate, I can't stress it enough. Nevertheless, it's still like allowed us to get rid of a lot of boilerplate. And now I believe the most interesting part kicks in, maybe the part that we skipped before. See, this class was defined, right, as a static class, but it was outside the main method. You see, there's this gimme stream method. But look what I was able to do with a record. I was able to declare a record inside this method, which means I can use this record only in this method. It's visible and available only in this method, not in like a till the very end, not in other methods or constructors or classes and whatnot. Only in this very method, in the scope from here till the end of the scope of this method. That's why even despite this, Java doesn't have anonymous tuples and requires named tuples. See, it's like creating a named tuple is really simple even inside a method, because right now, as a kind of a byproduct or side effect, also interfaces and enums can be declared as local too. So not only records, right? So let me show you that. See, this is also what changed in Java 16. So this is the we are inside a method. Please remember that we're inside a method, and we have a local record, just as we saw in the previous example, and then we have local enum and local interface, and of course local class. And this is not an anonymous class, this is like a proper class, and I'm able to create instances of them and use them. I mean till the end of scope of this method, of course. So let's run this. See, it works. So surprise, surprise, Java still allows us to be less and less ceremonial and verbose when we have to write our code. Okay, do we have any questions to that? I don't think so. So let me go for another topic. By the way, please keep asking questions live. Nevertheless, if you have any questions that you would like me answer later, for example, when you later watch this on YouTube or somewhere else, you can always send me a DM on my Twitter. I should move here. Yeah, here, like Piotr PRZ. Okay, so let's go for reflection of records. And also, I can't keep stressing this enough. If you have to do a reflection of records and you're not like a library or framework maintainer, I think something somewhere might have gone wrong, right? Because records should be used in a transparent way, because they are transparent data carriers. And when you have to do like a reflection, it either means you are like a library maintainer or a framework maintainer, or maybe consider that you are actually abusing the idea of records in Java. So we have a new method in a class, and this method will show us Boolean if a class is a record or not, pretty much like we have isEnum method. And then we can also call getRecord components that will give us an array of the components of a record of an object at hand. So I should have reflection here, like a little demo. I mean, we shouldn't be doing that, but let's do that for the sake of the demo. So let's run this code and let's cover this thing briefly. It creates a lot of nasty output, but don't worry about this. See, I have an enum and I have a record, right? So this is like a record, you see, and this is an enum, and this is a bin with setters and two fields, and the getters, two getters for these fields and one setter, because one field is final and the other is not. And I have two string defined, and I of course don't have to do anything like this for our record, because records have them generated automatically. So what happens when I run this code? Let's analyze this code. You see, I'm checking if an enum object is an enum, right? It is. And I'm checking if the record is a record. Yes, it is as a record as well. So from a record, we can get record components. As I told you, we get them as an array of record components. And then I can create, for example, a stream, or maybe I should go for like a proper for each loop, and I can investigate the components of the records. See, and I can get the value of the record by reflection, which means I'm going to call a crc get accessor, and I'm going to invoke this accessor and so on. So if you like do something in your library and you have such a library, maybe this is the way you should get values instead of calling set accessible true, because as we said 2 weeks ago, this is like calling the demons of the reflection. So we don't want to do that. You want to make sure that the class isn't record, for example, and then you will need to call record components, get their accessors, and iterate on these accessors and call invoke for each of them. That's what you should do, at least in theory. And then we come to a thing bin called bin info. So we have this bin info we can get using introspector, right? So as you can see, it's part of the Java Beans and desktop, mind you. Yeah, so this idea of Java Beans comes from desktop world, like Swing or AWT and so on. And when you get the bean info for a record, what happens is, as you can see, according to this bean convention, record has only one method which satisfies this convention, and this method is called getClass. It doesn't have any of these methods for accessors. And when we see that for bean info, it has not only this get class, which of course is like a default, and we ignore it, and we all know it's not like a proper property. No pun intended, sorry. And then we have this ID field, which was final. Therefore, we only have read method. And then we had this string field, which had this, let me find this read method, which is the getter. See, here it is a get prefix. And we also have this write method, which is de facto our setter. So as you can see, despite serving the same purpose, according to bin info, our record is not a bin. So please remember that records are not bins. They're not immutable bins. Records are records. Bins and bins are bins. Mutable, immutable, that's another story. Yeah, so this is how it works. Okay, and annotation propagation, I believe I was going to cover that briefly. Sorry, no, serialization of records. Okay, so let's go for serialization first. So one very important change when it comes to records is that records are reconstructed using constructors. So we don't, I mean, and I'm talking about this like, you know, serialization and so on, then Java native serialization, right? So they are reconstructed using records. So let me go for another demo, like, because in code we trust, right? I mean, slides and presentations can take everything, but the code has to compile and has to work. That's why I love showing you folks the code. So what does it do? We have two types again. We have, or classes should I say, sorry. We have this serialization record check, which is a record, surprise, surprise, with just one field, right? And we have, let me go there. We have this bean check, which again has just one string field, right? And it doesn't have the getter, by the way. It only, for time being, has this accessor-like method, right? So I was trying to make this bean look as much as a record as possible. Sorry. To make it mimic the record. And what happens then? So as you can see, there's a main method, and we're going to check serialization, like the Java serialization using serializable and so on. Yeah, see, this record needs to implement serializable. So by default, they don't implement serializable. And again, I think that's cool. And we are going to examine, like first serialize this object we get here to an array of bytes. Then we're going to examine these bytes, and then we're going to deserialize them. Okay, and yeah, so this is the serialize method, and this is the serialize. These are like technical. These aren't that much important. Okay, so these are just to get the bytes. Let's not focus about this. It's like a proper old, maybe even outdated, some would say, Java serialization. Okay, so as you can see, I was creating a record right in here. So this is creating this record, and this is, we are creating record for ABC123, and this was shown by this call. Yeah, so I have this compact constructor, and this is the side effect. Because I was creating this record here, and I called here this constructor, we saw that message, this very message, and then we were serializing this object, right? And these are the bytes we got, and then I'm deserializing the object, and see, we're calling the constructor again, right? Because this is the message shown by this compact constructor. And so let's keep the bytes, they are not that much important. And then I deserialize this record, right? And now we're going to do the same thing for this bean, yeah, for serialization bean check. And you see, I'm using exactly the same data, and then I'm serializing it. These are the bytes, and then deserializing. And as you can see, for every other kind of object, the deserialization process doesn't call the constructor. So again, this is a change, and I think that it's a good change, because the constructors should be used maybe for deserialization as well. One thing though we might to have a look at these bytes because the format, the binary format, is also slightly different. So if you could follow that, you see we have this 111, 111, and this is the same, but somewhere at some byte, I don't know which one, the format changes. So you see you have 97 here and 99 here. Right, so the format is different, also a tiny bit different for records and for bins, or at least we won't get the same array of bytes when serializing to a file or sending over a wire using, for example, RMI and stuff. So we'll get different results, and maybe that's the reason that libraries and frameworks need to adapt. Because let's talk about a different kind of serialization, right? Maybe you kind of guessed what kind of serialization we're going to talk about. So see, we have this faster XML JSON, right? And we might want to serialize our objects to JSON, for example, not only a binary format. So there should be an example called JSONification, right? And what I'm doing here, quite simple thing. I'm creating an object mapper, and what I want to do is I want to create first my bean, write it as a string, and then I want to write this bean here, and what I want to do is just I want to write this value. So again, I want to do exactly the same. I want to serialize and deserialize later on here a record, but first for a bean. So let's run this example, and what happens? This is what happened. So this is the JSON we got for this bean, right? And this is the constructor that's called, and so on. And why does this thing work? It works because on top of this field we have this annotation, JSON property, right? If I don't have this annotation, or if I don't have this annotation, things won't work. Because this is not strictly speaking a bean following this convention, because then I either need to annotate this field, right, or I need to annotate this accessor, or maybe I should have like a proper getter, and maybe that's the best way. But then to recreate this object, for example, I need to go for constructor properties to enumerate them, unless of course I want to create like a proper serializer or deserializer for JSON. So this is what's needed to make this Java bean to be like JSONable, so to say. Okay, let's see what happens for a record, right? Let's go and let's do the same thing for a record, and it doesn't work. Why it doesn't work? Because it's missing this annotation, right? So let's add this annotation here. That this is a JSON property, and let's run this example again. See, so in theory, this single annotation is needed to make record work nicely with JSON. It's just not even that line is needed, or this annotation, right? So let me comment this again, and let's visit the project object model, my friends, and let's go for our dependencies. Sorry, and this is the dependencies of records, of course, because the example consists of sub-projects. And let's go for JSON, at least in version 2.12. Let's reload. And yeah, indexing, new IntelliJ idea. Hopefully it will stop soon. You don't see that because the indexing it was behind my token head. Okay, let's go for this example again, and mind you, now we don't have this annotation at all, right? So let's run this example, and see, it works. So apparently you don't need any annotation, anything like that, for your records to be properly serialized and deserialized to JSON and from JSON and from JSON using faster XML's JSON. And why? Because records, and please don't forget that records are immutable data carriers, and they are specified by the language, by the Java language specification, so on and so on. Therefore, libraries can adapt and can use them nicely, right? So they can rely on this specification, and you can see the perfect example of this in Lombok, and it was also a perfect example of using using this preview feature concept, because then maintainers had like a year to prepare for records going live, right? So let me just go to annotations before we answer your questions, okay? So it's important to know that the annotations like added to components are propagated where the target specifies or permits to. Okay, so let's go back to this annotations example. Annotation propagation. Yeah, so as you can see, I have a number of annotations here. I have annotation. Yeah, by the way, we have a new type of target for annotations since Java 16. It's a record component target. And then of course we have all the ones we previously saw, like a field, method, parameter, a constructor, and so on and so on. And there's also having all like fat annotation. And then when I have a record and I use record and I toss all these annotations, like annotation that should be only on a parameter or a method or field or a record component on this fat annotation, and let's run this code. And maybe let's not dive deeply into every possible option. It's just you can see that I have this annotation propagated whenever it's needed. So as you can see, fat annotation got propagated pretty much everywhere. So it's propagated to the component, right? I have the fat annotation. It was propagated to a field because this is a field, right? A private final field, and I have fat annotation and so on. So fat annotation got propagated everywhere, but then the other ones were picky. So as you can see, the record component annotation was propagated only to component, and then the field annotation only to this field, and then of course nothing to equals, nothing to string or hash code. And then as you can see on component, like the accessor, I got the method annotation, right? And so on and so on, and even the parameters of the constructor got propagated annotations as well accordingly, of course. So this is how it works for annotations. So whoops, sorry, let's see if we have any questions to answer. I think we might have some questions to answer.
Yeah, there is actually one question from Pavel.
Yeah.
Would you recommend to use records with Spring data? I see they use it for non-mutable data, example, entities that are read-only objects. Will it work with Hibernate?
That's an excellent question, and we're going to cover this question in one of the following examples. I think we had one more question from Dappy, if I'm not mistaken. And I'm sorry if I'm misspelling the name. I read it.
Yeah.
It was something. Yeah.
Yeah, we actually skipped this one. This is about Lombok. So how Lombok applies for records? If, as you say, we have to sometimes override equals and hash code, can we annotate records with Lombok annotation?
If I may, I would suggest that Dappy should get another ticket, because maybe it's kind of a subjective, but I kind of feel or sense a friendly soul. Sorry. So let me go here. I mean, I was also intrigued by that, and I even it should be written somewhere here. See, so I kept torturing records. Sorry, I should change the view. I kept torturing. Sorry, misclick. Yeah, I kept torturing records on my blog page. And it changed throughout the versions, the preview versions of records in Java, like in Java 14 and in 15, and it also changed from one Lombok version to another. So now using Lombok annotations is pretty much restricted, and I would say it makes kind of a sense. It's just you see, it's impossible, for example, to use toString method and so on a record. And it is still possible to have a builder. It has to be used on a constructor. It doesn't work if you add builder on top of a class. It has to be on top of a constructor. So we can have a builder for records, but any other annotations, as far as I can tell, like getter and so on, they used to work in previous versions of records, like the preview features and previous versions of Lombok. They don't work anymore. And I'm not sure if that's good, if that's not good. Maybe it's good, maybe it's not. It's up to you. I'm not going to judge that. It's just I like this sick ideas. Just maybe I wouldn't do that in production code. And there are, of course, these concepts or questions how they compare to each other, right? So how records compare to, for example, value classes. So the difference basically is like that. So records are not Java beans, whereas the value classes are or the classes generated using value annotation from Lombok are still Java beans, right? So this is the difference between them. Nevertheless, they still should get similar mechanics for hash code, for equals, for these methods to extract data and for toString, and to have this all argument constructor, right? So the closest relative, although not exactly the same, is the value class, and this is it when it comes to similarities. Pretty much everything except that is different between records and Lombok. Okay, so if we don't have any more questions regarding that, let me go back to subsequent sections. And we'll get to this question of Pavel soon, I hope. We'll see that in a demo, basically. And please remember that records don't have any copy or with method, right? Like we have in Scala or we have in Kotlin. So the idea or the paradigm how to use it is basically that we have, even if we have like a pair like this, a generic pair, I'm not sure if it's good or the best usage of records, because then you might think that such a pair could replace the pair from Apache Commons, but then we get again to this point of mixing various types because we lose the type control and so on and so on. That's why I wouldn't recommend that, because you can mix the package sizes with properties of a car, like total mileage and trunk size. That's what I'm referring to. Nevertheless, we can't call any with method or copy. Now it doesn't even work with Lombok in the most recent version I have checked. And the idea is just we again use basically the constructor and we feed it with data that we get from accessors of the original object. So this is the idea how we should be like copying or cloning records in Java. This is how it's supposed to work. And that's why it's important, my friends, that accessors, equals, and hashcode methods obey the contracts they should be following, right? So this is why it's that important. Okay, so using records with other features, records already support pattern matching with instance of pretty much like everything else, and they work nicely with the sealed hierarchies. So a brief demo for that. We have other features here. Okay, yeah. So as you can see, I have a sealed interface bird, and if you don't know what sealed classes interfaces are about, please visit the channel of Wrocław JUG. Maybe we will add a link in the description of this recording where I explain the concept or the idea of sealed classes and sealed interfaces. Here we're just using it with records, right? So we have an interface, a sealed interface bird, and sealed means I need to explicitly name the classes that are able to implement this interface. And because they are in the same source file, I don't even need to do that, because the list can be generated implicitly on our behalf. And then as you can see, I have this duck record, which has a color as every other bird, and it has a swimming speed and flying speed because it's like a bird with extra properties. And then we have chicken, which has a color, and because for chicken we don't care how fast they swim or fly. We only care how much eggs they can give us per week. We can have a different implementation, and as you can see, we can run this again. Should work. Yeah, it's working. And as you can see, I'm using sealing, right? So one of the properties that's supposed to be a standard feature of Java 17, and we're using here the so-called pattern matching or smart casting that was described previously as well. So this is working as well, and it's working really, really nice. And in the future, they will support pattern matching, for example, with switch instructions, switch expressions, of course, and most probably even with deconstruction. So something, if you know Scala's, like an apply method. Let me show you. Sorry, let me show you that. Yeah. So there is. This is the list of the JEBs that we should see in Java JDK 17 in September this year. And as you can see, one of the JEBs proposed to target Java 17 is this pattern matching for switch, right? So instead of even using this pattern matching with instance of, we'll be in this sophisticated chain of ifs and else's. We should be able to go for something like this. And of course, records should be work here as well. And let me find if we have such an example here. Maybe we should have then not only guards, but maybe deconstructors as well. So we'll be able to extract some pieces of data from the inside. Or maybe it's not described here. Let me check. I can't see the constructors here. I mean, we'll be covering that, of course, in September or maybe a bit later when Java 17 is a real thing. Yeah, so as you can see, this is a future work as well. So if we have, for example, like a records for various expressions, we'll be able to deconstruct easily. So kind of like when you construct, you have I or you have left and right, and then we construct add expression, and using deconstructors on unapply, we'll be able to get this data back in such a switch expression, like in this case. And that's another reason why I would start using records instead of value classes from Lombok, apart from maybe that there's still some performance quirks and so on, because we will get most probably these unapply methods for free, unless something like this will happen for Lombok value classes as well. So as you can see, this is what's going to happen in future for records or two records in Java. And as you can see, they work really, really nicely with other features like sealing, like pattern matching, and so on and so on. They should be also be able to be used as value-based classes from project Valhalla. We covered 2 weeks again. So this should be working quite okay. All right. And let me see. Yeah, there is more on records if you're interested on my blog page. Several articles on records, how should be used, how they shouldn't be used, and so on and so on. Just this demo that Pavel was asking about. So let me open another project. I should have it like records lib demo. Let's open it. Yeah, and just a little disclaimer, because I'd like to show you how to use or how records can be used. Yeah, it's not a mistake with Spring Boot. It's just, please note, I'm using Spring Boot version 2.5. With that got released, I don't know, like a week ago, something like this. So it's pretty new and cool stuff. Nevertheless, for example, if you're starting a new project, why not use this version already, or why not to bump your previous projects, provided they are already working like that, right? And I have a simple project that's using Spring Batch and also a simple, super simple REST endpoint. So let me go for this endpoint perhaps, and let me show you this endpoint, right? So as you can see, it's a pretty, I mean, I don't know if you can get away with simplest or more demo-ish endpoint, REST endpoint. And as you can see, I have a request, and this request is a request body, and I'm constructing and sending a response, right? So basically, I'm supposed to get like, as you can see, I'm supposed to get like a string and return it in uppercase, and then I'm able to like multiply the value, like the power of 2, to return this this value powered by 2, like squared, something like this. All right. And as you can see, or maybe you can't see, but you're about to see this request is a proper like a DTO, right? And there is absolutely no reason for it not to be a record. So it's a record, right? And that's why this is everything I have to do. I don't need to add any other methods like a getters or anything. And as we will see in a moment, Spring should handle it. And the response as well, again, it's just a record, right? So I don't have this boilerplate code with getters and so on and so on. So let's give this code a spin. Let's see if it works, right? Hopefully it does. Okay, so let me copy this request. Let's go for a terminal and let's paste it. You see, it did the job. So, right. So I've sent this. Sorry. Where is it? Why is it? It's sorry. Yeah, this is the result, right? I forgot to hit enter, sorry. So you see it uppercased and squared, right? So it works. So there is no problem with using records in Spring 2.5.0 and onwards, like request bodies or responses or anything like that. The thing goes even further, my friends, because I also have like a Spring badge here, right? I have a simple job converting a CSV file to JSON, because why not? And I have this CSV file, something like this, and I want to convert it to a JSON, so to be something like this, right? And I have my job. And this is what it does. It has this flat file item readers and whatnot. It's just as intermediate type, as you can see in this job definition. I'm using name and email. And what's this name and email? Of course, it is a Java bean, right? So maybe you could try to use records here as well and see if there are any benefits. So let me select this all lines of code, like a 70 lines of code, or so maybe not like a 40, okay? And let's just turn these into public final fields. And then I'm not able to find out if you see this. It says class can be a record, but I would say we need one more thing, which is a constructor with all fields. And then let's go here and let's go for to convert this to a record. So let's click, and convert it to a record. Yeah, convert to a record. And as you can see, this is the record we have, right? So we don't have any more getters or accessors, explicit accessors or get or hash code or equals or tostring or whatnot. And when we try to rerun this application, sadly it blows, right? It doesn't work because Spring Batch expects us to have like this parameterless, like the default constructor for Java beans. And this happens only because we didn't update our job, because we're still using this target type, which means that it's expecting wrapper, bean wrapper, and so on and so on. So let's go instead for a field setter, and let's go for a new record field setter of name and email class. I mean, I would expect that this thing detects that it's a record and then does the thing under the hood automatically for us. Still, we have to do this manually. Nevertheless, it's an update of a single line only. And let's rerun this code. And let's see what we have. So this time, this job ran without any exceptions. And let's see when the data was written. It should be somewhere in log. I mean, pesky log, too much data logged. Let me find it here. Like it should be, I should be logging it to tmp, yeah, to this file, to this very file. So let me go again for a terminal and let's see what we have in this file. Right, see, so the file was generated for us. So the job does exactly the same job as before. It's just now instead of using this Java bean, I'm using record. So another area where you can start using records right away. You don't have to keep using beans, because this is like only a DTO, only a data carrier, nothing fancy, right? So this could be useful, I think. Okay, there was a question about entities in Hibernate, maybe like a bit wider about JPA. Yeah, thank you very much, Marcin, for highlighting this. Maybe I will switch to a screen only. Okay, so we have these entities here as well. At least I have prepared them for you. And this is like a proper JPA entity, right? Proper JPA entity or Hibernate entity, and I can use it as immutable Hibernate entity. As you can see, and I have this ID field, and I might add this constructor if I will, because why not? And this field, of course, is not final, and I need to have this parameterless or default constructor for GPA, and so on and so on. This thing works. It's just what happens when I try to do something like this again, only with a record. Let's see. Then I need to, what do I need to do? Yeah, so the package name, that's a different story. Okay, and then what I try to do, maybe you can see there should be like a red snake, we say in Polish sometimes, like a red line below indicating that this is an error. But is it truly an error? Because what does it say? It says that the class should have a public or protected no-arg constructor. And again, it's impossible because it will have this, it needs to have a parameter constructors, right, for this entity, sorry, for this ID field, and this field will become immutable. And besides, this record is final class, and classes cannot be, or entities cannot be final because they are proxied, right, by Hibernate or other JPA engines, so to say, and so on and so on. And the tricky part is if you go for like a Maven and compile, I believe. See, things keep working. The build is successful. Build success. So the error comes here only from GPA because I'm not running. From IntelliJ. I'm not running it, and so on. But you see, already the IDE can spot that this thing won't work. That entity cannot be tossed on top of a record because it won't work. There's a nice article from Vlad Michalseja, Vlad, Java champion, the Hibernate guy, explaining where we can use records for like data projections and so on, but they cannot be used for entity and for GPA or Hibernate. Or maybe they can, but because as you can see, I have this M entity bean here, right? And it looks like our entity bean, and I have this our M entity record. And surprise, surprise, I have a record here and I have entity here. And the question is, how is it possible that this time I have a record and I have entity here? It's possible because I'm using Morphia, which is an ORM for a Mongo database, right? And I can even prove to you that this works because I should have a test for that using test containers. Let's pray to demo goats now to make sure it works. Of course, it would take a bit longer because it's test containers, but still it was like half a second, as you can see. So the test works. So as you can see, for other ORMs, like for Morphia, for example, which don't require or don't see a problem with entities being final classes or not having like the default constructors, entities can be, or records can be used as entities, right? So as you can see, I can have this data store and I can save these two beans. Then I can find them using the data store. And even when I went for these fetch classes and I used actually like a native call on this Mongo container. So I extracted this data using Mongo container in a quiet mode, of course, to validate, to ensure that I have this data really there. So I hope this answers the question from Pavel. Yeah, so this is it for this question. So I think because I find this question interesting, and I also have this the privilege of giving give away the tickets. I will ask you, Pavel, to contact Marcin later, or so we can get the ticket for Java Love conference, and let's go and finish our demos. Yeah, so that was it about records. If you have any records, please put them still in chat, or contact me on Twitter or Telegram. And let's just skip, because we were talking about Unix domain sockets last time. Now this time let's talk about other changes, right, to Java. Let me just go back to talking head mode. all right? And so I think whoever they are, they kind of massacred my boy a bit. And let me show you what I mean by that, because now we have this two list method on a stream, and I'm not so sure I'm happy about this method coming to exist. And let me show you what I mean by that. So there is this little example. So see, this is this to list demo. So we can have a stream now, like stream of various elements, and then for example, instead of calling collect and collectors to list or to immutable list, we can just go for this and yeah, to list. It's just when I go like this and I go for a static import, right? Then it's only the matter of using this collect, these few characters. And some say, yeah, having this to list method on a stream is about to make, you know, less verbosity, less ceremony. I'm not so sure if this was such a big deal to make this explicit call to list, because with collect to list, because as far as I can tell, we don't have any method like to set, and I still need to go for collectors. So in my reading, many people will start abusing it, like instead of selecting the proper collection type, they will go for just to list because it's shorter, right? And I also can't accept an argument that this few characters of C O L K T, like CT, sorry, 7 letters, should make it really worth it, because still I can't have a val. Val in Java, and people keep telling me that I should instead go for a final var, right? So get rid of these 6 characters here, although I find them much more annoying than the collect here. Yet we don't have the collect now when we want to go for to list, but we still have to go for a final var, right? So that's why I kind of I'm not so sure I like this feature. What I like about this feature, though, it's like it's not that. Fortunately, it's not that bad, because the implementation is not equal to list, like collect to list, and that would give us a mutable list, but it's actually equal to immutable list, because when you go and see the Java doc of this code, you see what it actually returns is an unmodifiable list. So when I try to modify this list, I see an exception that this is unsupported operation. So maybe from this point of view, this would be a good change, because it will like drive people towards using immutable data structures. And I think that's good, because I perceive like mutability as performance improvement, which in many cases sacrifices the readability and safety of the data for performance, which might not be even the case, right? Might not be needed. And there are also other changes to Java 16, like we have a new datetime formatter flag or indicator, whatever it's called, of pattern B, and let me run it. Or maybe, yeah, I have the locale set to Polish, right? To Polish, and I used B. So B means or results here is wieczorem. It means in the evening, basically. When I go here for example, for German, it should get something like abends, right? So again, in the evening, and let's go for English. Why not? And then it should get like evening, in the evening. Yeah, exactly, in the evening. So for example, you'd like to show, instead of like just going AM and PM, maybe you'd like to show like it's like, for example, 7 in the evening, as we see it right now. And yeah, and now also the uncommitting memory in G1 can happen concurrently, so it doesn't happen in the stop the world pause, right? There's support for SH3 based signatures and this algorithm and so on and so on, apart of course from many more changes to security certificates, root certificates and so on. I encourage you to browse the release list on your own. Of course, there's experimental AOT and GraalJIT got removed from JVM. I mean, they were enabled or added as an experiment. Now they got removed. They were experimental. They were never meant to be used as a production. And finally, the methods, like previously we had the thread, stop and destroy methods deprecated on the thread. Now we see them also deprecated for removal in thread group. That's why when you see this thread group and this stop call, this stop is crossed out with a red, thin red line. Yes, it means that stop using it because this method might be removed in one of the future Java releases, maybe even the next one. We'll see that. Okay, so I guess that would be it when it comes to covering what remained for us in Java 16. So again, please, everyone, and for every speaker at every event, not just today meetings, provide your feedback. Let the organizers and the speakers know how they performed, what you'd like them to improve, what was okay, what wasn't okay. Unfortunately, I can't accept paper forms because we are doing this remotely. So instead, please go for this little poll. Even if you're not watching us live, if you're doing this in a synchronous matter, if you're doing this later, even like a year later, don't worry. Please just go for this little form. You see, it's anonymous. I don't know your name. It's really simple. Just select your answers. Let us know what you think. We will appreciate your feedback. And this is it. I hope now we covered not everything and not as deeply as I wanted, but in general I were talking for more than 3.5 hours on the changes in Java 16, what's new and noteworthy. I don't think you have any more questions. So if in case you have any more questions, please reach me out on Twitter or Telegram. You might visit my blog page for more stuff on Java. Here is the link to this presentation, to these slides, and here's the link to the code, right? And again, here is the QR code for these slides. I think this is it. Thank you very much. And Marcin, are we going to conclude this mini series of our JUGs?
Yes, I think so. So thank you very much, Piotr. It was a great presentation. Thank you all the participants for your questions. Yeah, and I think this is pretty much it. Then.
Yeah, so this is it, and now let's get ready for Java 17, which might be even more revolutionary in certain aspects. So yeah, keep updating Java, folks. Thank you.
Thank you. Bye-bye.